It's great to be here again, and I think that's true of you as well.
Yeah.
Both of us are active in the composite schemas working group, which is a working group that's trying to standardize federated GraphQL. I think this is sort of a three-part talk. I'll give a short introduction to federation. You'll go into a lot more depth on some of the topics we have been discussing in the working group, and then I think we're hoping for some questions and discussion.
Yeah. So we hope to have a more interactive talk where we also get feedback from you guys. So as we go in the details, you get the chance to chime in and influence maybe even spec decisions that we are going to do.
Yeah. Before we start, I'm curious sort of how many of you are familiar with GraphQL Federation in general or Apollo Federation. I think almost everyone, right? Maybe I should have asked this the other way around. Like who isn't familiar with Federation? Okay, so then I think this first part I don't really need to spend a lot of time on. There are a couple of things I want to mention because they've affected sort of the standardization process.
Go to the side so everybody gets it.
But I'm assuming you're all familiar with sort of the reasons for federated GraphQL, the workflow, and some of the terminology I think here is specific to Apollo Federation. We haven't necessarily adopted the same terminology in the spec, although I think most implementations use this terminology. So there's the notion of a subgraph. That's the unit of composition. There's the notion of a supergraph, the result of the process of composition. And the rules that govern composition, those are meant to guarantee sort of statically that a schema can be satisfied by a particular combination of subgraph implementations. And we've referred to that as the fundamental property of federation. This is something that we're sort of specifying as part of the standardization process, but informally, the idea here is that you really want to make sure that from the outside, there's no difference between a monolithic schema and a federated schema. Any query that you can sort of validly execute against that schema, we should be able to satisfy by breaking up that query into subqueries and fetching data from individual subgraph servers. So if you go into a little more detail on sort of what the composition model and also the resulting runtime model looks like, there are a few important concepts. One is entities. So the idea is that in any schema, there are types that sort of act as shared resources, as hubs or entry points. And these are types that are typically sort of spread out over multiple subgraphs. Multiple subgraphs contribute to the same type. An important decision we made with Apollo Federation, and that we've also adopted with the standardization process, is that we really don't want to rely on a single notion of identity. So we haven't adopted the node interface, for instance, or the idea that there's always a particular field that identifies a type, because in the kind of distributed systems we design federation for, there are often different ways in which you can identify and look up these entities. So for instance, if you think about a product entity, your product catalog might use like a UPC, like a normal product barcode, but your inventory system might have like an internal representation of a SKU, like a stock keeping unit. So you need both notions of identity, and you need ways of mapping between the two. We use keys to specify the various ways in which entities can be identified. There's also additional data that some fields require. And if this had been sort of a monolithic GraphQL schema, you would sort of fetch that data internally. You might already have it, or you perform like an additional database query. In this case, this is data that comes from other subgraphs in the same schema. So for instance, here we have a delivery estimate on a product, and in order to compute the delivery estimate, we, for some reason, need the size and the weight of the product. That lives in another subgraph. In Apollo Federation, we have a requires directive that specifies which fields it requires, and that then connects to one of the subgraph schemas. In the standardization process, we've made a few changes here. And one of the changes is that instead of a requires directive, which is sort of an implicit way to pass through this additional data, we've switched to normal field arguments. Let me back up a little bit. Oh, wait, wrong.
That's actually a good slide. Maybe start with the entities.
Yeah, I think that was actually the intention. So if you think about sort of what this means at runtime, the requires, there has to be a way to pass through that data to a particular subgraph. So in this case, for instance, we need to get the size and the weight from another subgraph, and then the subgraph that resolves the delivery estimate field somehow has to have access to that data. With Apollo Federation, we have a very dynamic mechanism to support this. And this is something that happens usually sort of under the hood by your subgraph implementation. If you're using a particular GraphQL server, you may not necessarily have to deal with this directly. But underlying what happens is we have a very generic underscore entities field, a root field. What it receives is basically a blob of data, an array of blobs of data. We use that to pass through this additional data. We also use it to support batching. And Michael will go into a lot more detail on sort of what the alternative to this is that we've developed in the context of the standardization process. But what I want to emphasize here is that although there are a lot of downsides to an approach like this, there were very good reasons for relying on this, because sort of the combination of dynamic additional data and requires and batching is not something that you can really support with a regular GraphQL root field.
Yeah.
Go into that.
And there's there was no way in GraphQL back then to do that basically over the transport or whatsoever. And now that we are doing it in the GraphQL Foundation, we can just change spec, right?
Yeah. So instead of relying on that underscore entities, we want to rely as much as possible on normal GraphQL features. We need some extensions to the transport, but for the entry point, we can actually rely on normal root fields now. And you might wonder sort of why we need any sort of explicit functionality here at all, because if you have a root field like product by SKU or product by UPC, it seems pretty obvious what that does. And it is pretty obvious to humans, but the semantics here are completely implicit. Like if you look at this from a schema perspective, if you just look at sort of what the GraphQL schema tells you, it only tells you that this takes a string and returns a product. It doesn't tell you that the product you return here corresponds to a particular lookup field, for instance. So we have a directive, a lookup directive, that you add to root fields to indicate the intended semantics. And there are some additional arguments that you can use there, and some additional directives to specify a non-standard mapping, but we'll go into that as well. Then for the additional data needs, we're relying on field arguments here instead of a sort of a field level requires directive. We now have a require directive on individual field arguments. What that means is in your implementation, you now get sort of typed data, and you have a standard way of getting access to it. Before, with the underscore entities, it was sort of server dependent how that data would actually end up in your resolver.
So this was a bit about the roots. And I'm going a bit into the new stuff. So one thing, the composite schema spec is also on GitHub. You can also read always into the current progress that we are making. It's also an open process. That means you can attend also in the meetings where we discuss features, give us feedback, and we strongly encourage that. So if you go to the GraphQL organization and then composite schema WG for working group, then a simple pull request allows you to take part in the meeting. The next meeting is cancelled because we are here on the conference. But usually we meet once a week, right? And it's a pretty open process. And the main drivers at the moment really are Apollo, ChilliCream, and the Guild that are driving this spec. But there are also others that came on, like GraphBase or so, that are nowadays also pretty involved in the process. Okay. But this means, like, if you're interested in that, just join us and become part of this process. So the specification you have here, and if you want to read into it, you can read into the active working draft. As I said, this is a living document at the moment. And what Martin talked about is just the lookup at the moment, right? And the lookup is a very central concept to the composite schema specification, and we even think it transcends the composite schema specification because it could in the longer term also be very useful for clients like Relay that could suddenly identify fetchability and identifiability of entities, right? So when we look at that, is that we specified how you can basically transition between multiple subgraphs, or we call them in the specification source schemas, because the GraphQL specification itself never talks about the term graph, but rather schema, right? Although it's called GraphQL, there's actually only one mention of graph, and that is the GraphQL name. So in Apollo Federation, you had always this key directive. We also have it. But in the context of the composite schema specification, it's just about identifiability of something. So we basically say this is an identity, or this entity has an identity here. If you want to move from one subgraph to another, you actually can use one of these lookups that tell you how you can enter a certain graph in your system. Like for instance, in this case, we have here a product that is being returned. So this source schema or subgraph offers you a product with a certain amount of fields here. In this case, it's even a union. And then the arguments into this lookup are the data requirements you have to provide to use this lookup, right? That's a basic mechanism. Okay, let's dive in. So when we started exploring lookups, and also in what we looked in the community existed, we thought we should use something like batch lookups. And you can see here, this is a batch lookup. What it means, it's an array of identifiers I can pass just into a standard GraphQL field, and then I get multiple entities back, right? It's an easy approach that also is very easy to implement. But when we started exploring these lookups, we quickly got stuck in a concept that are requirements. Requirements are additional data you want to have for certain fields from other graphs. If you think about distributed systems, like or mutations or whatever, often you need more data from other graphs that own this data, right? That you can inject into resolvers and so on. And with these batch fields, we can actually not do that, because if you think about how you would invoke that, let me check. Do we have that as a query? Yeah. If you think about how to invoke that, how do you actually pass for each item that you get back here an individual set of requirements? You could do that, right? We could say we have a top level requirements thing that is any, and then pass that into our fields that have these requirements. But that is, again, we are where we left up with a polar federation, where you have basically in any field to inject all the data into a subgraph. So you have untyped data you have to deal with, and so on. So this is actually what we didn't want to do. From a design standpoint, our ideal way to deal with this transition between subgraphs is to have single resolvers that deal with a single entity. Like if I want to have a product, I want to have just a singular field where I can pass in a single ID. And then I can also pass in for the single thing, the single requirement. But this also has problems, right? What do we do with batching? We cannot batch with this, and we would have an n+1 problem, and that is actually what we don't want in GraphQL, right? So we sat down, and because we are doing that under the umbrella of the GraphQL Foundation, we can also do a lot in the spec space to actually make this possible. Because this design is actually allows us to have no compromise on the API design, get a clear, understandable GraphQL, right? We have just simple fields that fetch entities. It's simple to implement and reason about, and doesn't compromise your type system with any types. And the idea is to introduce transparent batching. So you don't worry about batching. We're gonna do that on the transport level for you. And okay, this is a standard GraphQL request, actually the JSON that you send when you do a GraphQL request and against a GraphQL server. You can see here the query uglified, right, just to send it over to the server. And then we have down here the variables, which is an object. And what we actually want to do is to invoke the same query with a lookup inside multiple times. So our idea, which we came actually up with, is just make variables a list. And this is the invocations that you have for these queries. You can implement that very naively and basically do a loop on the server. That's not efficient, but with data loaders and so on, you can make that efficient, or you go more complex and really merge the execution on the source schema. But for the implementer of a subgraph, this is very nice because you just care about your single resolver. There's no complexity around batching, and then we're gonna handle this. Let me actually show you how variable batching works. Like if and now I need to wake up here. I use for the demo, unfortunately, container apps from Azure. They shut down, and if a distributed system shut down, every container takes 12 seconds to wake up. For a distributed system, this is unfortunate. Let's see. Now it's there. Okay. Awesome. So this is like a standard query plan that you could have. It looks, in every vendor, it looks a bit different, right? But you can see that we have here a lot of, yeah. You can see we have here a lot of distributed GraphQL requests. That's typically what happens in these systems. And you basically can pick then any here. Let's take this for instance. you can see this is a singular invocation here. And then we can just test this operation. And there you can see now this is the variable batching, so to speak, in action. We are basically invoking this query multiple times for each of the values that we got passed down by the query planner. And then we can just invoke it, and you can see here in the response, let me also zoom that in, just a second, that each of these responses have here a variable index. And that is the that is how the gateway knows, okay, this item here, variable index 0, has this result. This is streamable and allows us for out of order delivery of results. So if one result is is finished earlier, we can just deliver it and don't have to deliver in order these results. So this is pretty neat. And this bakes in the batching mechanism into the system itself, right? Into the GraphQL system itself, as the GraphQL over HTTP spec will have this incorporated. Okay, let's go back to the slides. All right. Well, yeah. We also not only thought about variable batching, but at the same time we also rethought request batching, because if you think about these distributed systems that fetch a lot of data from different source schemas, they also sometimes fetch from the same source schema but different data. And we thought it would be ideal if we not only can fold in this request to the same thing with multiple invocations, but also to fold in all these requests that fetch different things, right? So the request batching that we envision goes a bit beyond what Apollo has for their Apollo client. This way you just get an array back when you send multiple requests, but it allows you to actually send multiple requests if they that could be variable batches inside of a request batch, so to speak, right? And this can also deliver out of order. In this case, you get a variable index and a request index back. Yeah, as I already said, you have a stream of result, out of order delivery with that. Request batching and variable batching can be combined for more efficiency, right? You don't have to rewrite queries and collocate these root fields. You can send them in separate requests, have this nice isolation, but then the GraphQL server can execute that in an optimal way. And by the way, this also works like it's designed to work with the incremental delivery specification, or what you know as defer and stream. So we built that so you can use that with defer and stream in combination. And this actually gives you a lot of avenue. Like if you're building your own gateway, there are a couple of people that do that in this room, then you can actually make a very efficient query planner that asks for the requirements of something immediately and defers all the heavy data requests. And that also works with this protocol. Okay. We were, with the specification, also forward thinking. We didn't want to only support what is possible today in GraphQL, but also what is coming tomorrow, or I should say what came in September 2025 with the new GraphQL spec. So this is a standard lookup, right? We already talked about this. Actually, the example that Martijn had was you could get the product by ID or the product by name. But Benji actually brought us the one-off directive. Does anybody know one-off already? Is anybody using one-off? Ah, okay. This is actually really cool also for subgraphs, because now you can define your lookups with this nice one-off directive and just say, okay, this is my the type by which, or the fields by which I can fetch product, right? And then I can make such a lookup, mark it as a lookup for our distributed system, and query it like this. This is like how the user would query. Get the product by ID. Even nice to read, right? So in order to give the gateway information about what we are fetching here, we actually have this nice is directive. The is directive tells the composition and also the planner how to translate this, how to understand this object actually. So we have here a choice operator, and we're telling the gateway you can either use this if you have from the product, so the type that you return here, the ID, or when you have from the product the name. If you have either of these information, you can use me by invoking me with an object that has either of these things. Let me just check. Yeah. And this also works in the way that if you have different things here, like if this has a different structure than actually the output type, that is what happens in schemas as they evolve, then you also can map this. So we call this a selection map syntax because it's a merge from the selection set syntax in GraphQL and actually the value syntax in GraphQL. So you have the selection part. This is what selects data. And then you map the selected data basically into the object that you're creating here. One second. Yeah, this works also with deep objects. Like you could also construct more complex trees here. Maybe you can get the product by ID, but you also could get it if you have the SKU and the name in combination. This is a composite key that you could also construct. Okay, so this is it for lookups. Are there maybe questions about lookups? Go ahead.
So is the example correct here? You have the input type product SKU name input, but it's not used.
What is not used?
The input type. So you have SKU name as a string in your example.
Yeah, you mean?
No, in your product by input.
Ah, yeah.
So
Sorry.
that
Sorry, that was a copy paste error. This should actually be this type. So SKU and name should be this input. Well spotted. Other questions? No? Okay, let's dive into requirements. Are we short on time? Okay. Okay, let's talk about requirements. That's another part that makes federation, for instance, federation, is that you not only can stitch things together, like in schema stitching, where you say, okay, I have this resolver kind of way to think about things, but with requirements in federation, we could require data from other source schemas or subgraphs. And the way this works is not that you say, I want this piece of data from this other system. It's just from the overall schema that we composed, we want some data. And these requirements in the composite schema specification are not transparent in the way that we inject you a blob of data. But Martijn already explained, we have here arguments. And these arguments are annotated as requirements. On the public schema that the gateway exposed, you don't see this information here. Actually, let me show you that here. So when we set this, is it the right thing? Wrong. The wrong thing. Sorry. So if we, for instance, go here into the product, this guy. Thanks, Pascal. Then we have, this is a typical federation example, right? We have the delivery estimate, and delivery estimate has a zip that it needs from the user. So where do you live? So I can estimate how long it takes to deliver that. But internally, to calculate that, the shipping service actually needs a ton of data like dimension and stuff from other services. So these arguments that I actually need for injection on the source schema, you don't see them here, right? They are handled transparently by the system. And we use the same selection map syntax also here, where we basically say this field is a requirement, and we construct the requirement by referring here to weight, or even do these deep mappings where we wrap into the graph with this dot syntax. The path could be longer, and then map that to the object that we have designed as a requirement. So you can transform the data with the new requirement syntax there. It's not only that you have the selection set syntax to just require, but you also can transform as you inject. This can also work with more complex scenarios here. And let me zoom in. Like we have, for instance, this is one selection map syntax. You can see here the choice operator. That's the same choice operator that I showed initially with the lookup. But in this case, we are saying, so if this product has book details, so if it's basically a book, it has details about the author, I want to map that to the one-off field here as this kind of an object. So you grab into details. If details returns book details, then we construct this object here and inject author and genre. If this is electronic details, so if this is a piece of electronics, we're gonna construct the object with brand and model and map it on the electronics field. So this kind of requirement is actually one of the most discussed things in the workgroup at the moment, because we are not sure yet, right, how the semantics of this work. It's not about technical feasibility, but how people understand it. An alternative to that at the moment that we discuss is kind of this guy here, where we just map all at the same time. And if it's not electronic, this basically is deleted out like it's nothing. That is also an approach that we could take, but it's not encoding the one-off style that nicely. So both approaches we are discussing. We are also discussing other pieces here, like maybe instead of having all these things listed or the choice operator, maybe we introduce something like a question mark here to say we have a fallback way to for instance, have a dummy object here. This syntax with requirements opens up a lot of new feature segues we are exploring. Not only that you could do this mapping from source schema or subgraph data, but you could also have variables in there. Because I said this is the GraphQL value syntax, and that means we could introduce like variables where you can even ask for what are the gateway headers that were passed in. Or you just ask for the currently signed users that is there, for the error status that happened while invoking this other subgraph, right? This is the opt-in value that we have. It will not be in the first iteration of that, but it's where we could go with this. Think about the context data work Apollo did, right? With the context directive?
From context.
Yeah, from context. But the new require style that we are talking about allows us to incorporate actually these two contexts into a single API, where you can suddenly do that and then customize even your gateway with these custom data in the process. Are there questions or feedback that you have?
Will I be able to reach parents or siblings?
Yes, because like that's already possible with the from context. You can push data down, right?
Yeah, it establishes a dynamic scope, so you don't directly depend on parents or siblings, because that makes you dependent on the particular structure of a query. So you probably don't want that. But what we've done in Apollo is we have the notion of a context, and dynamically, as you traverse a query, that context gets set and can be read by these requirements. So for instance, if you go through a current user field, that could actually set the current user, and then one of your fields further down could depend on that, or it could depend on the locale or the store, any dynamic context. So without making you dependent on the particular structure of an incoming query.
Yeah, so this is a way to extend that, and this is a future playground for us to look where we can help you. Also, if you think about things that you do with connectors and things like connecting to REST APIs and things, and then injecting this data into other source schemas or subgraphs. What do you guys think about? So one thing we are really.
I think there was a question there.
Oh, sorry, didn't see you.
Kind of similar to that, but in the examples, it's all in like a string. Are we thinking about making this something that's more like easy to handle with the schema itself and have validations on those?
Like this thing has validation. It's not, while it's a string literal here, right? We use a directive system here. While it's a string literal, it's in the composition process. This is fully evaluated, and like there's also, depending on the implementation of your GraphQL system, this could even depends on if you're doing, for instance, implementation first. You don't see that even, right? This could be just your Java code or whatever that translates into that. So I don't think that we have. Yeah.
We have another question.
I was going to ask the context sync that you shared. Is
Yeah.
it talking about with defer or async thing as well?
That's a good question. I'd have to ask our router team. Not sure. No, I assume it would, but there might be subtleties there.
Yeah, one piece of feedback maybe we would like is at the moment we have this choice operator here, and this basically also looks clean, right? This basically looks if the field details return to book details, electronics, or closing details. If these are types, object types, this is very simple, right? If this become interfaces, this switch case kind of API becomes more muddled because like all of these cases could be true. What we discuss at the moment is to take the first one that is true, and this will be the constructed object that we inject. But is that even something that people understand? Is that confusing kind of API? Or would you like more a more condensed API like this, where you have to figure out it's null if it's null, but it's not encoded that we have here a union? Or maybe something with question marks?
Yeah.
Go ahead.
For our use case involved, I think I would likely more that we're gonna go for the second one.
For this one?
No, yeah, this one.
For one-offs?
Yeah.
Okay.
So it's either, how I see it's like different use cases. It's either book, electronics, clothing. If it's not there, then it's fine. I'm not gonna do anything with it.
Yeah, it could also be both there, but then it's a subgraph error, right?
Yeah.
Yeah.
But it also depends on whether you map to a one-off or not, because there might very well be overlap between these, and in some cases that could be fine. Like if you're mapping to a normal input object, and for
Exactly.
instance you have maybe you have physical dimensions and you have some other properties, and like some of your products have physical dimensions and others don't. I think it's a more flexible model, and one-off sort of forces you to choose one.
Where this like this is really one piece where we are not sure. That's why it's important to get a bit of feedback.
Test it with all of us.
Yeah.
You have the options. Which one would you choose in
Exactly.
situation?
There are a couple of others, right? This is a very simplified thing. What if you, like in a choice, have two fields that you map, right? And then just one of the this is a type condition, not a generic. It's very misleading. But if one of the type conditions is true, one is not true, right? Would you discard the whole option? And with this syntax, it's more clear, right? You would take just both. It would be clear that you take whatever works, right? And then the source schema rejects it or not. Okay, that is
So maybe one option too is instead of having that as a one string, as we mentioned before, can we have each of those conditions on where it maps on the input field? So on
Yeah, I know what you mean.
on the book, you'd have only the details with details part. On the so it would be a directive for each field, probably.
I think the issue with that is that like the mapping applies to the field that uses the input object, and that input object might be used by multiple fields. Yeah. So the mapping is specific to that location.
Yeah. Also, the lookup might be used as a composite in other inputs where it's maybe a nested input in some other inputs. Sometimes it's non-nested, it's top level. So this way it's flexible. You have the mapping syntax, and then you construct the input and inject it.
Couldn't this one be used together with the other one? You know, the 2 and 3 combination.
These two,
Not
two.
this one.
Yeah, this. I mean, this is probably we are going anyway this way that you can do question marks here, and also with defaults, because this gives a lot of flexibility. For instance, you could say if some subgraph has this data, or if the data is on the context or something like this, you can create these conditions. We probably will go there. So.
Can we please have all 3?
Yeah, I mean the choice operator where it's really nice is with the lookup. So I think we're gonna have it here because here it's very clear 2 choices for the injection, right? Whereas on the requirements is where it gets muddled and where we also have the contentions in the discussions. Yeah. Is there anything else that you have as a feedback for us? No.
We have 1 more minute.
Yeah. Go ahead, Martin.
Just one question. The things about having an array of variable sets or batch queries that have that can be used without federation or anything like that. It's just a general thing on GraphQL.
Exactly. It'll be part of the transport.
Yeah.
GraphQL
So I
or
could
HTTP.
use it in my UI to make a batch query.
Yep.
Yeah, if you read anything about the composite schema spec is not batching, it's often because people just see the singular field, but don't understand that the batching is actually transparent over the transport. Good.
So the syntax you're discussing for the mapping here, are you also consider adding it to the GraphQL spec in general? So I know a lot of clients really want to unnest things in their query, so the period syntax to
There are discussions. That's why the syntax looks like it looks, because we are also having discussions on the flat chain syntax. But we are moving the composite schema specification is its own specification in the GraphQL universe, like the transport specification. And having this, like if this is accepted at some point, and we say, okay, this is a final thing, then it doesn't mean that that you will have that in the core spec as well. But we are going in that direction to enable these things. Yes.
Because if that is the case, then I suspect less would be more.
How do you mean?
In the sense that the more syntax you propose here, the harder it will be to get it also pushed upstream.
So the key to understand with the syntax here is that this is actually already today GraphQL syntax, except for the dotted syntax, because this syntax here, if we grab that, expands to actually just a selection set here. So the syntax, let me show you that next to each other. This syntax, right, is this syntax. Just that we combined the input object syntax, the value syntax, together with the selection set syntax. So you see the selection set you have here, the type condition, and this is actually just a compacted form to write the same syntax. So the only new thing we introduced here is actually the flat chain syntax, as the proposal is for the GraphQL specification.
And there's actually an existing issue about that on the,
Yeah.
the GraphQL spec repo. And it's been open for many, many years, but it's definitely something that I'm interested in pursuing.
Yeah. But we don't want to, like in the GraphQL Foundation, we don't want to block something, like features shouldn't block each other. So, but if we go forward with this dotted syntax, it's very strong indication that it will be a dotted syntax once we get it into the core spec.
So in this example here, so I would have expected the one-off directive here to, like, from the discussion, right? Because that's what you're trying to say, right? It's one of these.
Yeah.
So, but then, of course, there is maybe no obvious place to put directives.
Oh,
No, I know, and also the fact that this maps to a one-off is a property of the specific input type that you're
yeah,
mapping to.
it's a
So,
type.
so you could also map to a normal input type that doesn't have one-off semantics.
So if that's why it's important to see like the one-off. If I go back to the query, the initial one, is that here? Yeah. So this is how I invoke a one-off query in GraphQL. There's no one-off that you see here. It's just the property of this field of the input type. So
Thank you. It's a lot to take in.
Yeah, and I think we're running out of time.
yeah, but it was great discussion. So if you want to get involved, join the working group.
Yeah.